Hi, Assalamualaikum and a very good morning. So now we're going to do chapter 9, which is carbonyl compound. And we're going to focus on the subtopic of 9.3, which is preparation of carbonyl compound. So in this video, we're going to explain the preparation of carbonyl compound through the method of ozonolysis of alkene. And then second, we're going to do the oxidation of alcohol. And then number third is we're going to do the Friedel-Crafts acylation in order to produce the aromatic ketone. Okay, so the Friedel-Crafts acylation, we have looked about it in the chapter of benzene, and now we're going to look at it again in order to produce the ketone, which is a aromatic ketone. Okay, so without any further ado, let us start. So now, ozonolysis of alkene. So ozonolysis of alkene will produce aldehyde or ketone or both. So this is going to be dependent on the attachment at the carbon-carbon double bond. So we're going to look into the attachment here. So now let's say if we have a C double bond C where this carbon is attached with two R group, this one is attached with one R group. So when it is undergoing ozonolysis followed by the reaction with zinc and hydrolysis of water, what you're going to do is you're going to break the bond here. So as a reaction of breaking of bond, what you're going to produce is RC double bond O and R. So this one is produced from this side here. Okay, and the name is ozonolysis, so we're going to add oxygen to the C double bond here to become C double bond O. At the same time, on this side, what we're going to produce is an aldehyde. Okay, so you're going to become CR C double bond O H, and this is going to be known as the aldehyde. Okay, now we're going to do another example, which is a cyclohexene. So when cyclohexene undergoing ozonolysis in the presence of zinc followed by the hydrolysis of water, what they're going to do is they're going to break the bond here. So this carbon here, which is attached with R group as well as H, and here is also the same because C and H here, what they're going to do is they're going to cleave. Dia orang akan diputuskan. So daripada satu gelang, so you can treat it as a cyclic, right? So bayangkan satu gelang, when it is broken, it's going to become a straight line chain. Okay, so it's going to become 1, 2, 3, 4, 5, and 6. So you're going to draw 1, 2, 3, 4, 5, and 6. And then at carbon number 1, it's going to become C double bond O and then hydrogen here. Same goes to the carbon number 6. Okay, so you're going to draw it as like this or like this. Okay, so this is going to produce aldehyde at both ends of the carbon chain. Now, let's say if we have another structure here. So when we undergo ozonolysis, so it's going to break apart the C double bond here, which is an alkene, which followed by the zinc and hydrolysis of water. What we're going to produce on this side is we're going to produce a ketone, and on this side we're going to produce an aldehyde, which is the methanol. So we're going to draw it as CCH3 and double bond O, and then what we left on the right hand side is that we have CH and double bond O here. So this refers to a ketone, and then this refers to aldehyde, or known as methanol, because it has one carbon. This one is known as propanol because it have 3 carbon. Okay, so that's all for the ozonolysis of alkene. So via ozonolysis of alkene, we can produce aldehyde and also ketone. Now we're going to do the oxidation of alcohol. So oxidation of alcohol we have met in the last chapter, which is the hydroxy compound. So aldehyde can be prepared by the oxidation of the primary alcohol by using the PCC, which is the mild oxidizing agent. Okay, so when we have our alcohol here, which is a primary alcohol, when it reacted with PCC, which is the pyridinium chlorochromate in dichloromethane, what they're going to do is they will undergo oxidation. But then it only happen very mildly. Okay, mild maksudnya lemah, oxidation agent yang lemah. So what they're going to produce is an aldehyde. Okay, so let us look into another example here. So let's say if we have the ethanol, when we react it with PCC, which is the mild oxidizing agent in dichloromethane, what we're going to produce is ethanol. Okay, so the number of carbon is still the same, which is 1 and 2, but this side here going to become double bond O and H, and this is known as ethanol. Okay, at the same time, the oxidation of the secondary alcohol can be oxidized using any oxidizing agent, and this is going to produce a ketone. Okay, so the general reaction is when we have a secondary alcohol, so this carbon here is attached with two alkyl group, and then it's going to be oxidized with strong oxidizing agent in this case. So you can use PCC as well because it doesn't matter, you can use any. And then when it react at acidic condition at high temperature, what they're going to get is a ketone. Okay, now we're going to look into the example, which is 1, 2, 3. So we have a propanol, but then OH is at carbon number 2, so it's going to become 2-propanol. So when it is oxidized using KMnO4 at acidic condition at high temperature, what they're going to produce is propanol, which is an example of ketone. Okay, so C double bond O, CH3 and CH3. So this one is a ketone. 2-propanol become propanol. Okay, and this is the summary of oxidation reaction that you have learned in chapter 8 basically. Okay, so just now we have looked into this one, which is primary alcohol react with PCC will get aldehyde. Secondary alcohol react with any oxidizing agent will get a ketone, which is example of the carbonyl compound. Okay, but also know that the primary alcohol, if you uses strong oxidizing agent, we are gonna get the carboxylic acid, but here is not the focus for this chapter. Okay, but for tertiary alcohol, it cannot be oxidized because there is no hydrogen that's attached to the carbon. Okay, so it is like a revision to you back again. Okay, now we're going to do the last method, which is the Friedel-Crafts acylation. So it is a good method to prepare aromatic ketone, and the reagent that we need is acid chloride in the presence of the Lewis acid. So acid chloride here refers to C double bond O and Cl here, and this can be anything, alkyl group or aryl group. Okay, so the general reaction, let's say if we have benzene, and then we're going to react that with RC double bond OCl, which is an acid chloride. Okay, what we're going to get is the aromatic ketone, where the C double bond O are going to be attaching at any of the hydrogen. So they will undergo electrophilic aromatic substitution, the similar thing that you have learned in the chapter of benzene. Okay, and it needs a Lewis acid here, which is the aluminium trichloride. Okay, so now let us do another example. So we have a benzene, and now we're going to react that with a benzyl chloride here. Okay, so what we're going to do is that we're going to attach the C double bond O benzene here to any of the hydrogen. So when we react that in the presence of Lewis acid, what we're going to produce is the benzophenol. Okay, so here Friedel-Crafts acylation is only applied for benzene ring, and it is used to prepare aromatic ketone. Okay, now we're going to do the example question in order to prepare carbonyl, either aldehyde or ketone. So for this part, we have to show the synthesis of methanol. So methanol going to be like this, one carbon and then hydrogen on both sides. So this is methanol. And then from ethane, so ethane will have two carbon, one and two. So ethane here. So it's going to be CH3 here and CH3 here. Okay, so now you have 2 carbon in ethane. In methanol, you only have 1 carbon. So you know that you need to cleave the bond. Kita kena putuskan rangkaian karbon-karbon supaya kita mendapat 1 carbon. So we know that we have to undergo the process of ozonolysis. Okay, because ozonolysis will be able to cleave the bond in order to make 1 carbon. Tetapi ozonolysis only happen for alkene. So we have to change it into ethene first. Okay, and ethane cannot be directly changed into ethane. We have to change it into chloro or bromoethane first, and then you undergo dehydrohalogenation into ethene, and then you undergo ozonolysis to form the methanol here. So let's do the step one by one. Okay, so you have your ethane here. What I'm going to do first is I'm going to replace one of the hydrogen with Br. So I'm going to do the free radical substitution using bromine in CH2Cl2 under UV. So one of the hydrogen here going to be replaced with Br. Okay, so here I'm already produced a haloalkane. But now I'm going to produce an alkene. Okay, so what I'm going to do is I'm going to do the dehydrohalogenation where I'm going to use KOH ethanol under reflux. So Br going to be removed and one of the hydrogen here going to be removed. So I'm going to got a alkene here. Okay, so from the alkene here, I need to undergo ozonolysis. Okay, so ozonolysis is I need ozone O3 followed by zinc and hydrolysis of water. So the numbering here is important because it is done step by step. Okay, so ethene here will have hydrogen, 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 and hydrogen. So when you cleave the bond, what you're going to get is H, H, double bond, oxygen. Same goes to the other side of it. So what you're going to produce at the end is a methanol. So from this reaction scheme, you know that you can produce a methanol from ethane. Okay, so from ethane you go into bromoethane, and then you go into ethene, and from ethene you go methanol via ozonolysis. Okay. Now we're going to do the next question, which is provide the preparation of cyclobutane to cyclobutanone. Okay, so cyclobutane going to have 4 carbon, 1, 2, 3, 4, and then I'm going to produce cyclobutanone. Okay, so what I'm going to do first is I can undergo free radical substitution as well to make it as a Br. So I will get a bromo cyclobutane, and then I'm going to change it into OH here, and then from OH I'm going to oxidize it into here. Okay, so this is the method in order for me to prepare a cyclobutanone. So this is my idea. So let us draw it nicely. So we have our cyclobutane, and then I'm gonna do the free radical substitution, which is bromine in dichloromethane with the presence of UV. So this one is very compulsory. Without UV it cannot works. So it will undergo homolytic cleavage and then a free radical substitution. So one of the hydrogen is taken to be replaced with Br, and then I will undergo I will react with the aqueous sodium hydroxide at high temperature so that OH can be used in order to replace the Br in order to produce a secondary alcohol. Okay, and the secondary alcohol can undergo oxidation with KMnO4 at high temperature at acidic condition in order to produce a cyclobutanone, which is a ketone. Okay, so this is how you prepare it step by step. All right, so I think that's all for today's video. See you again some other time. Bye.